Hello everyone. Let's go through detailed examples of generator functions in order to understand how the yield statement works. I have a few examples as part of this slide deck. I'll be going through each of these examples using Python Tutor. Please feel free to copy paste each code snippet instead of typing to follow along with the demo. I just want to mention one thing about Python Tutor with respect to visualizations for generator functions. PyTutor does not do a good job of creating meaningful visualizations for generator functions. I'll explain in detail as we go through the first example here. Before we go through the generator function example, I just want to go through a simple function example which is not a generator. Let me define a function f, and I'm going to add 3 return statements into the function for returning 1, 2, and 3. Let me go ahead and call the function f, and I'm going to print whatever is returned from that particular function call. Recall that when you have multiple return statements, the minute you encounter the first return statement, your function invocation will be done, and you're going to just return the value 1 for that particular function invocation, and your entire program here is done, correct? Let's talk about how to convert this particular function into a generator. It's very simple. You just replace every return keyword with the yield keyword instead. Let me go ahead and do that here quickly. Notice that now when I'm calling the function and printing the outcome out of it, I'm getting a generator object. Before we talk about what a generator object is, I want to show you how to use the generator function. Instead of calling it directly, you'll have to call it within a for loop. So you'll have to say for x in f and print x. Let's go through this particular code snippet. So the function call for f is going to happen inside your for statement. What will happen is that you'll go ahead and execute that particular function, and the minute you encounter a yield, you're going to send back a value to the place where you're calling that particular function. So this is the stop and resume kind of feature that generators have. So you're going to stop the generator's execution, and you're going to send the value into the variable x over here. So you're going to have the value 1 yielded from the function into the variable x. So here is the first problem with Python tutor visualization. PyTutor shows the yielded value's return value, which is incorrect. The next problem with PyTutor visualization is that this particular function frame will vanish the minute I hit next now. But that's not really correct because you're not done executing the function f. The frame will still exist for the function f. You're merely yielding the value because you're following the stop and resume behavior. You're stopping the function execution in order to send the value 1 as the yielded value into the variable x over here. So when you print x now, you're now going to get a value 1. So now when the second iteration of the for loop executes, you're going to resume the function f wherever you stopped, and you're going to run into the next yield statement. So you're going to yield a value of 2. So now print of x is going to display 2. Similarly, the next iteration of the for loop is going to yield a value of 3, which is going to go into x, and you'll be displaying x as 3. Please make sure to understand that every iteration of the for loop does not call the generator function. The function call for the generator itself happens only one time. You are merely getting the value which is yielded out of the function for every iteration of your for loop over here. So this is going to have a similar behavior even if I have a bunch of print statements inside my function. Your function call for your generator is going to run up until you encounter a yield statement. For example, let's say that I'm adding print a before yield 1. and I'm adding print B before yield 2, and finally I'm adding print C before yield 3. Let's step through this example over here. So the function call for f is going to be made initially in your first iteration of your for loop. What are you going to do then? You're going to run the function. You will be printing A, then you run into a yield statement. So you're going to go ahead and yield 1, which is going to go into the value of x over here. So you'll display 1. For the next iteration, you're going to go back to the same place where you left off. So you're going to print B, and then you're going to yield 2. For the final iteration of your for loop, you're going to go and print C, and you'll be yielding 3, and you'll be done with the entire function execution for the generator here. Let me switch back to the previous version without the print statement before going through the next example. So I showed you how to call the generator function one time by going through the function invocation as part of this for loop statement. You can call the generator function multiple times by using different for loops for it. For instance, I can call it a second time by again saying for x in f, print x. Let's go through what is going to happen here. So the first invocation of the generator function is going to get started, and you're going to yield 1, which is going to go into x. So you're going to display 1, and similarly you're going to go back to the function definition where you left off, and you're going to yield 2 for the next iteration. So you're going to display 2 in the next iteration, and finally you're going to go back to the generator function to yield 3, and that's going to be the last iteration of your first for loop over here. What happens after that is that your current execution of the generator function gets completely done, and you go ahead with the next execution of the generator function. So that's going to be a brand new invocation of your function, and you're going to go through the exact same process. Function f will yield 1, so x will display 1, and then it will yield 2, so x will display 2, and then finally it will yield 3, and you'll be done with the entire program over here. Let's make it a little bit complicated. Let me add this for loop inside the other for loop over here. So I'll have to use a different variable for my inner for loop. Let me get rid of the outer for loop print statement, and I'm going to say that print x and y over here for me. There are 73 steps for this particular code snippet. I'm not going to go through all of them. Let's go through a few of them to understand what's going on. So I have an outer for loop which has a function invocation for the generator function f. So the first iteration of the outer for loop is going to make the generator function yield a value of 1. What are we doing then? We'll be running the inner for loop, which has another function invocation for the generator function f here. So that's going to be a brand new invocation. So that invocation is going to yield a value of 1, which is going to go into the variable y. So now when you display x and y, you're going to get 1 and 1. What are you going to do next? Recall that in Python, you should always finish running the inner for loop before you go back to the outer for loop's next iteration. That's how nested loops work. So you're going to run the next iteration for the inner for loop. So in the second generator function call, you're going to yield a value of 2. So now if you display x and y, you're going to get 1 and 2. In the next iteration for the inner for loop is going to give you a value of 1 and 3. What's going to happen next? You're done executing the inner for loop for the first iteration of your outer for loop. So you're going to go back and run the next iteration of the outer for loop. Recall that we left off the outer for loop's generator function invocation at yield 1. So you're going to resume wherever you stop, and you're going to yield 2 for the next iteration of your outer for loop. What are we doing then? We are then executing a nested for loop inside the outer for loop. So you're going to repeat the same execution of the inner for loop, which is going to create a third invocation of the generator function f here. So that particular invocation is going to yield 1 first. So you're going to get 2, 1 as the output. So if you keep stepping through, you'll be able to understand that this particular program generates as output all the combinations of the values 1, 2, and 3 here. Let's try and understand what exactly is a generator object now. So far we have discussed about how to use a generator function. Let's talk about what exactly the function returns here. So going back to the first example that we covered for generator functions, recall that when I print the function invocation for f, I'm going to get a generator object here. That's weird, right? We never returned anything from inside the function. How come the function is returning something? All the generator functions which have yield statements return a generator object. So you should be able to capture the generator object into a variable. So let me go ahead and define the variable as gen for generator. And I'm going to show you how to use the generator object. Let's go through the next function call. Whenever you have a generator object, you can call the next function on it. So next function is going to take as argument the generator object itself. Let me show you what next function here will return or output. The next function here will just go back to executing that particular generator function, and it will give you the first yielded value. Since we haven't run the function yet, the first call to this next function is going to make you yield the value 1. So let's go through this particular code snippet. So I'm just storing the return value of the generator function into a variable called gen. That's going to get displayed as generator instance in your global frame over here. A lot of people interchangeably use the term generator instance and the generator object. Generator instance refers to that particular instance that is being returned by the function invocation for that generator. What are we doing next? I'm calling the next function on the generator, which is going to execute the generator function, and it's going to give back to you the first yielded value. So that's going to be 1. So you're going to go ahead and display 1 here. I can make the next invocation to the generator function by again calling the next function, and that's going to yield a value of 2. Let me go ahead and do it one more time. That's going to yield a value of 3 over here. What will happen if I call the next function one last time over here? Notice that we are getting an error which says that we have a stop iteration exception. We are going to talk all about exceptions in the next lecture. For now, you just need to understand that you can only call the next function the number of times that you have the number of yield statements for within that particular function definition. So let's go through one more example using the generator object instance here. Let's say that instead of making one function invocation for the generator function, I want to go through 2 different invocations. So the way that I'm going to do that is I'm going to define 2 different generator object instances, and I want to interleave a few next function calls between those 2 generator object instances. Let me go ahead and change the variable names here to G1 and G2. I'm going to call next on G1 first, then I'm going to call next on G2, I'm going to call next on G2 again, and I'm going to say next of G1 and next of G1. Let's go through this example from the first. Line number 6 creates a brand new generator object instance and adds a reference to that into a variable called G1. Line number 7 creates a different generator object instance for a different invocation of the generator function f. Now when I call next on G1, that's going to start executing the function f, which is associated with the generator object instance G1. So we are going to yield a value of 1. When I say next of G2, that's going to create a brand new invocation of the function f, and that's going to yield a value of 1. When I say next of G2, we are going to yield a value of 2 because we just left off G2's function call at yield 1. So next of G1 is going to go back to the first execution of function f, and it's going to yield a value 2. Finally, next of G1 is going to yield a value of 3. I did not actually complete all the next function calls here. If you add a next function call to G2 generator object instance here, that's going to again yield a value of 3, and you'll be done with the function execution for both of these generator object instances. The for loop, when you say for x in f, is actually calling the next function every time on the generator function. Let me prove that to you. I'm going to go back to using gen as my variable name for generator object instance, and I can say for x in gen print x. Recall that we used to say for x in f. Since we are able to extract the generator object instance for f, we could just say for x in gen. Every iteration of this for loop is going to call the next function using this generator object instance. I'll wrap up this video here. In the next video, we'll be discussing the concept of iterables and iterators.